Hello and welcome to another Cloud Podcast, a podcast designed to bring you stories from the smartest minds in IT, operations, and business, and learn how they're using cloud technology to improve business and the customer experience.
All right, well, we're excited today. I'm especially excited today because we have Chris LeBeau from Advanced Technology Services. He's a director of IT, cybersecurity, and it's just a pleasure to have you on the show, Chris. Thanks for joining us.
No, it's great to be here. Thank you.
And Jeff, good to see you again. I always like having you along as my co-pilot on these podcasts to talk technology. Good to see you again.
Pleasure being here. And hi, Chris. Good to see you again.
Good afternoon.
So, Chris, one of the things that we like to do at the beginning of the podcast is just to give the audience and the viewers a chance just to get to know you a little bit. If you could just take a minute, 2 minutes, just to give them a background of how you got to where you're at Advanced Technologies and just that career path and how you got into technology and cybersecurity.
Sure. I think it started with being an underachiever in high school. So I sort of looked at college like high school with bills, and that didn't seem very appealing. So I decided I was going to join the military and then kind of re-engage my education on my own terms. And my dad gave me a very good piece of advice. He said, look, you can do that, and there's great benefit in doing it that way, but try to pick a skill or a field that's always going to be there and always going to grow. And he spent his career at the telephone company, right? So I looked at basically two different fields. One was medical technology, which fit that definition. And then the other was communications. So I ended up in the Army doing satellite communications, was part of something called Army Space Command. It was a fantastic job. And all the requirements to progress through that sort of changed my view about learning, right? And what it meant to really engage material and get smarter and learn more and be capable of doing more. All the things I didn't pay attention to in high school. So it sort of changed my trajectory a bit. So I did that for about 6 years. And when I got out, the Telecom Act was the next big thing on the horizon, right? As they had deregulated the phone company a few years previous, now they were opening up long distance. But before that, I worked for IBM for a little while and then went from IBM to Ameritech, which was the telephone company here in the Midwest, and worked on their long distance project. Very cool, trying to build something from the ground floor up within the safe space of a large company like that had been doing it for, 80 years at that point. So really learned a lot. But as that sort of changed, right, that market moved very quickly and everything commoditized before we ever really even got done with that project. And then came voice over IP. And I went to work for Cisco Systems and was a consulting systems engineer for a few years, working with service providers that were trying to bypass the phone company. So that was sort of an interesting adventure. And sort of from there, I did some independent consulting and ultimately came across ATS through a partnership opportunity. At the time, they had a outsourced IT services division in addition to their industrial services division. And they were looking for a program manager to help them scale. And so this was 11 and a half years ago. I arrived at ATS and they said, look, you're going to be a program manager. You're going to figure all this out. You're going to develop new services and you're going to help us get bigger. And I'm like, okay. And they're like, oh, by the way, network stuff? Great. Why don't you manage the network systems for the whole company? Oh, okay. So they had that team. Then the next day they're like, oh, you did service support and call center services and all that in your time at Ameritech? Great. Why don't you run our help desk? And so on, right? So I eventually got more and more responsibilities and ended up running all the operations for the IT services division. And over the period of about 2.5 years, we went from about 20 million to almost 50. And had dramatically expanded our scope of services and did a whole variety of other things and started to invest in new technologies that would improve the way we delivered that service. And along the way, we had a corresponding director of information systems that worked on SAP and a lot of the core systems. That person left, and they ultimately asked me to take on all the responsibilities for the company about 9 years ago. So today I own all the network, all the security, information security, and all the application development for the variety of businesses that ATS has.
That is quite a story for a high schooler that didn't want to go to college.
That's a great story.
It just shows you though, and this is, kind of off topic, but, to say to an 18, 17-year-old, hey, go figure out the rest of your life, at this college at such a young age, it's just so young. I think, the military is a great stomping ground to kind of figure yourself out, especially for, I think, us men, as we get into our 20s, it's like, what am I going to do with my life? And it gives you that chance to sort through all that and kind of find a path. without having to do it right out of high school. So I think that's great.
Along the way, I feel kind of cheated, right? Because nobody told me that, like, golf pro was a job, right? I didn't know you could go do that. There's all these other jobs that I wasn't aware of. So now I do this. But anyway,
we kind of got sucked into technology, right? Without knowing we could all be golf pros.
there was a point it was just
Right.
too late, But
Yeah.
anyway,
Yeah.
Chris, I'm in the Midwest too, and it's been a long time since I heard the name Ameritech. So that's an interesting flash in the past to hear you talk about Ameritech. It was
it was a big
our
circle.
offerings too. Yeah.
Yeah, it was the Bell system, AT&T, then SBC, then now it's all AT&T again. So
right, because I'm in Indiana, so it's Indiana Bell, and then it converted to Ameritech.
Yep.
So tell us a little bit about what ATS does and what you're responsible for. You gave a little bit about what you're doing now and all the responsibilities that have been thrown onto your plate. But as a company in general, like, what does ATS do? How do they go to market? What's changing? What do you see happening just in the market in your industry?
Sure. So ATS, Advanced Technology Services, about 35 years ago, was a division inside of Caterpillar. And it was Caterpillar Advanced Technology Services at the time. And our founder, a guy named Dick Blotto, said, look, there's a lot more technology coming onto the factory floor. My team maintains that. They do a good job. That's a sellable service. Why don't you let me go do that? And they did. And he went off and he was successful. And he later came back and said, hey, this isn't your core business. Why don't you sell me the division? And they did that too. And that's ultimately how ATS was formed. And they had a big marketing department, so they took the C off the front and just left it Advanced Technology Services. But that was in 1985. Started with about 35 people, and the whole thing was about that technology aspect on the factory floor and working with that level of automation, which was reasonably new at that time.
Wow.
Along the way, so it started as an IT company, but primarily with an industrial focus. And along the way, they added IT services. I mentioned when I joined 11 and a half years ago, that was a big part of the business. It was a division. But the biggest part of the business is industrial services. So we do outsourced factory maintenance, which means we come in with our teams, our technology, our programs, and we take over maintenance as a function inside our customer factories. So we're looking at the way these machines run. We're learning, things we learn at one customer, we can translate to another, just like any other leveraged service provider. And my challenge really is to build the tools and technology that help us, assign our work, track our work, reflect value to the customer, start to learn more about how these machines operate so that we can become more predictive and spend less labor doing it. Being a labor intensive company today, we're really trying to move to be much more data driven. So over the last really 9 years in this role, we took what was an internal IT department running a lot of old systems that were sort of put in because they were needed to run the company, whether it was an old finance system or old HR system or whatever, and modernizing everything to the point where we put the company in the cloud on solutions that will continue to improve themselves, right? And then our job is really to be an integrator. What we've also done, though, is we've taken the primary tools that we use to deliver service and we've designed and built those on our own. So we've built a lot of things that are specific to enabling our people, getting information out of our customers' environments, correlating that information across sites. In the last 2 years, we put together something we call Reliability 360, which is sort of a control center concept that has visibility over all those locations and is there for high level troubleshooting, the coordination of subject matter experts, identifying opportunities for improvement and communicating those to all the places where that improvement could take place. Really taking everything we know and doing a lot more with it. So that's been an interesting challenge as you look at, how do I take non-value added labor activities like running around with a clipboard taking measurements and start to do that with a sensor? How do I take a critical piece of equipment and start to understand how it's performing versus waiting for it to break and surprise me? How do I use that information to predict when I should act when new conditions come in? So for example, somebody comes in and says, hey, we got a big order, we got to run heavy next week. What's the increased likelihood of failure at that higher volume? And should we shut down and do some repairs ahead of time? It turns us much more into a maintenance advisor with a much better understanding of how the customer environment works, our role in it, and our ability to perform and basically give them uptime, capacity, and reliability as outcomes. So it's pretty interesting. We're primarily in North America, but also Mexico and Europe, primarily out of the UK.
Yeah, that's really interesting. And I like how specialized that niche is for you guys and how you're creating software and processes specifically for that industry that are unique to you, and having that intellectual property to be able to go to other units and other manufacturers and say, find things that work and repeat it. And it sounds like a lot of what you're doing in IT is business related as well, because most IT executives we talk to, they're just keeping lights on. They're not as involved on the business side to increase revenue and make things run smoother, as far as the business side. So how have you seen that in your career as far as being on the business side versus just kind of maintaining with IT?
Well, what's interesting is that, as I progressed as a technician, you would think of everything in terms of inputs and outputs, right? So when I have a bad input, that means my problems are coming from somewhere. So as I progressed through my career, I always wanted to get on the other side of that and fix those problems, only to realize there were bad inputs coming in there too. So you're always kind of chasing that continuum. But at the end of the day, what I learned along the way was that technology is only the right answer if you've asked the right question. And it only exists to support some business activity that people are interested in either buying or selling or both. So it's really about the role of technology. I used to be incredibly technical, routers, switches, telephone equipment, all of that. I couldn't do any of that anymore. My job today is to really know what technology is for, the role it plays with the business, and make sure the people that do know how to do that have what they need to understand how to hit the right objectives. They've got the right amount of capacity. They've got the right amount of funding, working within the constraints every business has to try to hit the objectives that we have. It's been an interesting process. My job is still a great mix of making the phones ring, keeping the lights on, but also working with our business leaders to understand the challenges they have in the market, things that are working against them in the field, things that customers are looking for that we don't have, and then trying to synthesize all of that into what should we do next.
Yeah. And as far as, yeah, go ahead, Jeff.
Go ahead. No, I was going to say, I think it's really interesting to me to hear the Caterpillar story, because many companies have built things they're very proud of, within their own four walls, in order to do what you're talking about, to be able to manage their floor. And it is fairly new, because we're not that far from those printed routers that used to travel with materials as manufacturing did what they did. So it is a fairly new area. And the fact that Cat, understood what ATS was, and we're able to realize that they had made something that others could benefit from and get it out there and market it. I think that's fabulous. That's, it came right out of the four walls. How could it have been designed any better than coming right off of Caterpillar's floor? It's fabulous.
Yeah, and it doesn't always happen, right?
No, it doesn't.
You won't make the leap, right? You never get that breakaway moment. For any number of reasons, but it's a unique story, and it's a very cool company, and we're doing some interesting things. We talked about sort of, I guess the buzzword, and I suppose this is probably a future question as we navigate this, but digital transformation, right?
Oh, yeah.
That's the word of the day. And so as I look at our journey where we've modernized a lot of our systems, what we've really done is put ourselves in a place where I don't have to rethink the way I do HR. I don't have to rethink the way I do finance. I don't have to rethink any of those things. I can now really focus on how I combine all these capabilities into new value for customers. And if you think about being a labor-based outsourced service provider, a lot of what you build is about improvement. So again, we're performing this function inside the factory, and what do I need to know in order to be able to do that? I've got to understand the right mix of skills given the environment I'm going into, job descriptions. I've got to be able to recruit and hire those people so that I have the staff I need to perform the service. I've got to be able to train those people and improve them from a level 1 to a level 2, or however that's designated. I've got to be able to keep them safe, right? Because nobody wants to work for an unsafe company in that type of environment, and certainly nobody wants to hire one, right? These are dangerous places. I've got to assign them work, track work, report on work, do all of those different things, have a method of operation, all of that. Those are all things that we've built to be better at what we do to provide those outcomes, right? Availability, capacity, and reliability. But every one of those things is available to everybody else performing a similar function. So, any service provider, you basically have to look at who you are and how you do what you do. What value does that have to other people that may not make the leap to pay you to do it for them? Can you help them? Can you augment what they're doing? Can you be an advisor? has what we've learned over 30 years of doing this, operating currently in 100 different plants in multiple different countries, a dozen different industries, and all kinds of different products. We're able to make, we're able to learn more. We're able to make different types of investments. We're able to consolidate activities. And you look at any individual factory trying to replicate or walk up that ladder, it's pretty steep, right? Where you talk about what you can then do as a service provider is walk in and provide them an outcome, a way to do it. It shortens their time to value. It's more economical, gives you more scale. And then it's that whole service provider thing where it sort of feeds itself.
Yeah, and it's just something that the expertise just isn't in every factory. Not every floor's got the ability to do this. If I could, real quick, Alex, I'd like to dive a little deeper into this because I know the audience is going to care about a couple things that me as a former IT exec thinks about. First off, when you're doing the things you're talking about, preventing unwanted repair, preventing downtime. So I'm sure you're doing work with the infrared, looking at circuits. You're doing vibration analysis, correct? Yep. I assume. But what you're doing through all this process is you're generating mounds of data. And the biggest thing that I would see when I thought of shop floor systems and data collection and trying to understand furnace profiles or gauge profiles on coils, et cetera, is how do you manage all that data? So you are managing a mound of information for these companies. And whether you keep the bulk of that data within your walls and how you interface to bring the important data to your clients. I think it'd be interesting to hear how you talk about how you handle that massive data and what you do make available to your customers.
Yeah, so the first thing is, where does the data come from, right? It's a byproduct, at least in the case of our work order data and the activity tracking, it's a byproduct of a service contract. We're performing that service for the customer. Now the customer owns that data, but at the same time, that's work we performed against common industry assets that has a value with a larger pool of such information. So we think of it like healthcare information, where, if you abstract or take out certain details, you still have a lot of usable attributes and information without being able to designate who it was for. So that's a lot of what we do, right? So for example, a 50-year-old male that has high blood pressure that lives in this zip code, right? That doesn't mean anybody knows it's me, Same thing with the customer, right? And even with monitoring data, where you're integrated with a machine tool or tied into a customer's operational network, it's a different story. That's a much more complicated, almost project-based integration. But if you're putting discrete sensors on existing machines, typically it's encrypted. It doesn't mean anything until you contextualize it. In the case of temperature, great, it's 85 degrees until you know where and on what motor, at what plant, for what customer, it doesn't really mean anything.
That's so
true. Sort of by design, segmenting how data is created, abstracting the sum total of that data so that it has a broader value to everybody that's participating, and then where and how you contextualize the data that you're collecting over and above, regular work order or activity-based data is important. And we've put a great deal of thought into, the design, where we put that, how we manage it, how we secure it. In the unfortunate event that a contract ends, that discussion about data ownership, it's already been had, right? So there's an expectation of what's going to occur at the end, and there's no confusion about that. And we're able to share that back to the customer. And like in all cases, without the context of the applications that made the data, it always doesn't mean the same thing when you spit it out. But we do try to do a good job with that, so that there's some residual value for the work we did, because we did that for them in partnership, right? A contract. So all those things are important, but now we're getting into more complex questions about the data. You get into machine learning, pattern recognition, all those different things.
Yeah.
And I'll use a simple example. Is a lot of these plants are in the southern part of the United States, or even in Mexico, where it's generally quite warm weather-wise. So what is temperature's relationship to failure? Right. Well, I have weather data, accurate weather data, going all the way back to 1950 something. So I have that to work from. I have all the failure history on a timeline for all the work I've already done to the plant. And now I can walk in today and add an ambient temperature sensor and sensors on particular pieces of equipment. And I can start to build a correlated model that helps me understand the relationship of temperature to failure. So again, that goes back to that scenario where the plant manager comes in on a Friday and says, hey, we got a big order next week. And oh, by the way, it's going to be 103 degrees every day. What's my risk? Well, if I know production volume, I know the temperature forecast, I could pretty much go in and say you have an increased likelihood of failure on these 3 or 4 things. Let's shut down, replace those. We have a much better shot of getting through the week without incident. And that's just a simple example of how you can take everything you already know and start to mix it with other data using these new methods and techniques. People talk about artificial intelligence like it's an outcome.
Right.
We have AI. Oh, great. But the questions are, what are you doing with it? And I always kind of in my head substitute, when somebody says that I'm using artificial intelligence, I sort of substitute it with, I'm using internal combustion. Okay. Are you building lawnmowers or are you building Formula One engines? Right. There's a fundamentally different set of questions you're trying to answer with that technique or that technology. Just because you can say, you're using it doesn't necessarily mean anything. Like all things IT, there's a lot of hype.
And AI is definitely the buzzword out there, right next to digital transformation, right? And we've had a few guests on the podcast and talked about AI and the big thing that the takeaway that I have had with some of these guests is that AI, you just don't plug it in and off you go, you're good. It's the input output, asking the right questions. And then not only that, but it's the training of it. They say, treat it like an employee. If you don't nurture it, care for it, train it, and grow it into what you want it to be, it's not going to work. So how have you seen AI working or the machine learning, what do you want to call it, like with what you're doing and how that's changing how your organization looks at projects now?
Well, there's the art of the possible, and then there's the limitations of the practical, I guess, is kind of how I always approach it, right? So, if you look at what AI is, at the end of the day, it's some form of math. So the question is, what are you really trying to accomplish? What can you do? So, for example, one of the things that we're doing is, because we're in so many different places, we have so many different types of machines we maintain. The question is always, what can I build or where can I focus that has the most value, the most places? Right. So one of the decisions that we're always faced with is the unknown in terms of predicting when something's going to fail. Again, conditions in the factory are going to change. Is there a risk associated with the equipment that I'm going to depend on with those changes? And so what we've tried to do is introduce things like remaining useful life calculations. And that's a trainable model, right? So for example, you'll get a little bit of data and it'll approximate, what hang on one second. Sorry, I clicked the wrong button. I wanted to not answer the phone. You'll get a little bit of data and it will give you an approximate remaining useful life on that item with a very broad degree of confidence. It doesn't know, but as it gets smarter and it gets more data and it gets more examples and all those other different things, that line of when it thinks it will fail will move and your confidence about that date will increase. So, where we find common applications, we have quite a bit of data to lean on already that we can bring to bear for a new instance of that same thing. But almost anything we're monitoring, we can begin to start to learn how it behaves and start to use that information to inform when we maintain it, how much energy we put into it, what the risk of it failing is, all those other different things. So that's sort of our approach, is to sort of practically take these tools and use them to change the behaviors that result in, frankly, more labor or more work or more wasted effort. So if we can remove that frees us up to do a lot of other different things. And now you get into automated responses to failures and things like that, which is sort of the next frontier, where I'm not just learning how equipment's performing, I'm now responding to the information it's giving me and making changes automatically.
Right. And the big thing here, just like you already said, all of this data, for it to be able to be a later response after what you've learned, you have to absolutely have saved all the parameters that made that made that situation what it was, so that you will, because you have to compare when you have that next red light go on, you first have to make sure that all of your environment and everything matches as well, so that you know that your response is appropriate. So that's it's complicated. It's a big deal. You're to be applauded for figuring out how to do this. It's not easy.
Figuring it out. Yeah.
Not easy.
It's always about the approach. The false positives are a huge problem, right? Just because you can monitor something doesn't mean that you should, or that you're going to get what you want from doing so. So you've really got to kind of monitor these things and baseline them. What is normal? I have 2 identical motors running in 2 different factories that have slightly different applications. I'm going to get completely different behaviors. So I've got to be able to observe and monitor and determine what normal is there, and then react to abnormal. So there's a training aspect. There's the ability to set the appropriate thresholds. There's time. It can get tricky if you want to get super complicated with it. And again, you always kind of have to fall back to what's practical. Yeah, I could do that, but there's a unintended consequence to doing that. I'm going to back off a little bit and stay here because that's where the most value is.
Yeah, and there's always, there's a tendency at times to overcomplicate things that don't need to be overcomplicated. Just because we can pull thousands of data points and plug it into a AI machine doesn't mean it's always the best thing to do, right? It's like, keep it simple, make it practical, so you actually get the results and get the information back that you're looking for, not just throw everything in there just because we can nowadays. One of the things that you touched on earlier before we started talking about AI, and that was a little bit about security, and you just mentioned it briefly, but I know security and AI, those are two big topics right now that are just on the top of everyone's mind. So going down the security side, and we talked before this podcast a little bit about it as well, like, where do you see the challenges arising for your organization with security? Because you are getting information from all these different plants, all these different companies. How do you see that evolving, and how do you guys mitigate some of that risk?
Yeah, I mean, so like every company, we have all the same security challenges anybody else does, right? Identifying our assets, securing our information, putting controls around it. We're spending a lot of time today around the concept of the extended enterprise, all the partners and vendors that we're interconnected with that support various business functions within the company, and being able to make sure that they're doing things consistent with what our goals and objectives are, and that we can prove that to each other. So that's what every company is doing. But in the industrial space, factories are interesting in that they're unique places put on the earth to make something no other building was put on the earth to make, right? So in some cases, they are very different from one another. They have many common challenges, but most of them are old. And when they were built, the internet wasn't a consideration, or the plant didn't need to be networked in a lot of cases in order for it to operate and continue to run. And any investment in changing the way it works usually comes with an opportunity cost, right? You have to shut down, you lose productivity, all that. So the investment cycle for these factories is typically very, very slow. And the operational technology, the controllers and all of these things are often running, really old embedded operating systems. Like in some case, Windows XP, a special version made for that particular machine. And of course, the minute you plug any one of these things into the internet, you're exposed to every known vulnerability for that particular operating system. So the challenge for us as a service provider is that, if we had the data, we can do X, Y, and Z, and that's valuable. But the plant can't give it to me in a safe and secure way, or it becomes a project that, if you added up the cost to do it, maybe doesn't, it hurts the business case of doing it, right? The investment is inordinate. So the real challenge for the manufacturing industry, I think, and their strive for Industry 4.0, which is that modern factory concept, is to create a safe data exchange, right? So each individual plant can collect the data locally and then potentially upload it to some kind of service layer where service providers like us and manufacturers and others can interact with it. Because otherwise, we've got to go to each individual plant and on a project by project basis, try to figure out how to get this information and address all the security issues of that one particular location. And that's difficult to do, right? So it's much better if we can put all this in the middle and everybody can interact with it. But that's a shift in the industry. That's not something I can necessarily control directly, but it is a barrier to entry, right? It's a barrier to value. The fact that I can do all these things doesn't do me any good if I don't have the fuel, the data to be able to do them. So, to get that connection, to get that figured out, I think is going to be important. And many manufacturers are making the investment. Some of them very slowly, some of them are making a big play in this space. But we deal with a lot of small to mid-sized manufacturers that, they don't have the resources to step up and do that. So we're looking at partnerships around operational technology, security, and compliance, where they can come in and do audits and take a look at where the risk really is. Other providers that can come in and do network projects that can create a better environment for the customer and a safer way for us to get that information. We obviously can't do all that for them. So those are some of the challenges that we have. But if data is that's the new landscape, right? So how do we connect all this stuff together in a way that makes sense for everybody and is secure?
Right.
And
things
Jeff,
like segment. Huh?
No, I was going to say, Jeff, you probably are dealing with the same thing before you retired. Like, how do you look at security, and just piggybacking onto what Chris said?
Well, really the thing, and as Chris, I was going to ask you about, you've got a plant maintenance system of sorts, right? I mean, you do, and you're going to have to interface that to all these companies' enterprise systems, for some level, because they're going to want to understand the work orders, the high level information, not the raw data, not the machine data, but the higher level data. And what you get into, Alex, is how do you segregate this information? How do you segment your network to make sure that these control machines, like Chris said, probably aren't even of a operating system level that you could even put today's protection, to make sure. So you can't face this equipment to the internet at all because you can't protect it. But you need to get the information moved, over from this segment that you must keep completely dark into a segment where the data can be readily available. And that's really the big challenge. And that's why, I'm sure a company, like ATS can always help people do this. This is the kind of thing that people with in-house expertise can't always handle, right, Chris? They need without your help. It's a very complicated. And then when you add the amount of data that comes out of ML type of engagements, then you've got a double-edged sword that you're trying to deal with. So that's why I admire what you're doing and understand the value.
Well, they're all different, right? I mean, I could have the same control in two different plants performing a similar function, but they're programmed differently. So even though I have a protocol converter, I can talk to it. I don't know what it's telling me until somebody explains it to me, right?
All right.
Map to it and work with it, right? So there's just a lot of challenges in that space, that make it interesting. What we are trying to do, though, is our applications, we're trying to build them in a very modern way, right? Where we can share access to them for different roles at the customer. We're not necessarily doing all the work. Sometimes we're working with engineering teams and others that are there on site, and we want to see all that activity the same way. We're building in authentication mechanisms that are consistent with commercial applications. We're building an API layer that allows us to sort of transact with these external systems versus these integrations of years past, where it's a project to set it up and maintain it, or moving flat files of old data back and forth. That's never quite right. We would rather exchange the right information at the right time. But in order to do that, you kind of have to look at it like an equation, right? If this is the answer we want, where do all the variables come from? I have half of them, you have half of them. Where does this data come from in your environment? And then try to focus your integration or your communication between systems on those elements, so that when things happen, that data makes its way over, and now your equation's complete and you get what you wanted. If you try to do too much, or it's too wide open, it usually turns into a project that you don't like what you get at the end. You spend a lot of effort to get very little. But if you're focused about what you're trying to accomplish coming in, and you know what feeds it, it's much more targeted. Then from there you can do anything, but at least you're doing those things right out of the box.
Mm-hmm. Sounds good.
Yeah, you mentioned that some organizations or manufacturers are trying to get there, and sometimes the barrier of entry to do it might be too high. Do you find that with industries that are more equipped to make that jump, or are there specific industries that kind of like it's going to be harder for them to make that jump just because they're just more archaic in general, just as over like a blanket statement?
Yeah, I think your process industries are more apt to get there, because in many cases they already have some version of a control system to monitor the process. So they're already sort of thinking in that mindset and have some of the basic things there. And in some cases, they're even making data that we can use from a maintenance perspective, if we have visibility to it. They're generally a bit more mature. Now, it depends on the industry and the process. You have customers that make, cold rolled steel and all kinds of things like that. Yes, it's a process, but it's not at all like a food production line.
Right.
In many cases, the machine breaks down. They have one right next to it that does the same thing, and they'll just use that one. And some industries use run to failure as a model, right? But when something fails, it surprises you. So surprise avoidance becomes an outcome there that we like. So I mean, there's lots of ways to look at it. I think it really does depend on what they make and how they're set up from a production standpoint. Net new factory, yeah, they're going to have all that. But what is interesting is I did a seminar earlier in the year about IoT monitoring and all that. And there's a concept about the connected machine. And so I buy a machine tool, it has a controller. The OEM, the manufacturer of that machine, can talk to it, and they're getting all kinds of data. And that's fine, except that machine is step 3 of a 9-step process. So in the context of my process, how useful is that connection, and the fact that that information is going outside of my organization and I can't use it? So it really is about context. It's about, the usability of this information. And then the other thing that introduces is IoT. It's better today. But 3 years ago, I have a slide that has about 800 different logos on it, broken into different categories. And the point is that every one of those people solved a problem with the technology of the day and their own innovation, which means in most cases it's proprietary, which means it doesn't talk to anything else, right? So there's lots of ways to solve a problem, but your approach has to be able to scale. You've got to be, it has to have longevity. You've got to be able to add new things to it. And most of those are what I call kind of like services on a stick. I have a sensor, a gateway, and a dashboard, and that's it. It just goes straight up, right? I can't add anything else to it. I can't do anything else with it. I can't send that anywhere else. We find a lot of that stuff embedded in customers' environments because they needed a solution to a problem. They found one and then realized they had other problems, right? And that typically becomes our opportunity to work with them to potentially add, additional visibility and look at it a little bit different way. And then that's the challenge that we have, is that we're working in 100 different plants, a little bit more than that today. I don't control a single one of those environments. So everything I need to be able to do, I have to figure out how to bring there or install there without having to turn that into a major one-off project that's unique to that location without value elsewhere. And that's not easy.
No. Do you see the industry evolving? Because we've worked a lot with commercial contractors, and it's the same thing, because they have everyone's got a different language on their programming, and that doesn't all talk to each other. How do you see that changing in that manufacturing side, where the suppliers to the machines, right, that are making the conveyors and all the different aspects to a manufacturing plant, getting together and saying, let's have a common language that they all kind of can go off of? Like, where do you see that changing?
I don't know. I didn't make the manufacturers conference this last year. It was all virtual. I usually like to go to the show and talk to people. So I didn't do the online version this year. But what I noticed, IT moves very quickly, right? Things are changing all the time. And if you look 5 years ago at phone systems, they don't look like they do today, right? So we started this conversation. The manufacturing world moves slower. And these machines are big capital investments that sometimes are depreciated over decades. So the rate of innovation doesn't necessarily reflect the rate of consumption in the market for these machines. What I do think, though, is that there's going to be increasing pressure from customers to say, look, if I'm going to put your machine in my environment, I need to communicate with the other machines, and they do it like this. I think you're going to see that sort of services layer sort of create itself, which will be protocols and standards for communications and interoperability. We have this in the IT world with things like SNMP and all of that. And I think you'll see some version of that start to form. And even over the last 3 years, the IoT space has converged around a few protocols and standards that have increased the interoperability of different vendors. But it doesn't mean that people didn't put in proprietary things they can't buy any more of. There was an article about 4 years ago about smart cities and cities that were putting in automated parking meters and all this stuff, but they were doing it using proprietary technology. And the estimate at the time was that there could be $80 billion spent on bad smart city technology based on being ahead of the curve and going too fast and picking solutions that weren't standards based from vendors that won't exist by the time the project's done.
Right, for sure.
Which is pretty scary because that's all taxpayer money, right?
That's right.
Don't worry, the government never wastes taxpayer money.
That's true.
So I really like where this is going. So how about just a little bit more on security before we wrap it up? We talked a little bit before about just government regulation and where you see that coming in on the security side to make it, so there's a protocol around it, right, that companies can follow. Do you see that? How do you see that evolving, and where it is now to where you think it'll be in the next 5 years with having some sort of regulation by the government for a security standard?
Well, the regulation, how you codify that into a bill or a law or a set of requirements, I think becomes a second part of the conversation. But so I'm a member of something called InfraGard, which is a joint venture between the FBI and the private sector around critical infrastructure protection. So I'm actually the sector chief for the Chicago area InfraGard chapter for manufacturing. And that allows me to interface with about 13 or 14 other people that cover the other areas of critical infrastructure. And it's interesting to see the commonalities, right? So for example, you look at programmable logic controllers, right? The computers that run factory machines. Those are used to raise drawbridges. They're used to run water treatment facilities. They're used to do all kinds of things. So it ends up representing a common vulnerability in a lot of different places where bad things can happen. Power generation facilities, I mean, all of that. So there's definitely some attention that needs to be paid there, sort of at a tactical level. I think when you get into the regulatory side of it, I talked about third-party risk and sort of vetting our vendors and all of that. Our customers do that to us as well, right? And I think all over the place, people are exchanging security surveys, and all they're really doing is injecting projects into each other's organizations, because every survey is a different format. It may be a question you've seen before, but they've asked it differently, or they want to see the answer in a different format. We don't have a common way to exchange information about our security posture to one another. Now NIST, 800-171 for non-classified, non-federal systems, or 53 if you work with the federal government, is a really good structure. But it was not really auditable before, right? I mean, I have a NIST program. I run all of our stuff that way, to that guideline, including all the policies, procedures, documents, controls, and all of it. But nobody would believe that, right? I have no way to prove it, other than to answer all the questions appropriately when I'm asked. Well, the CMMC is a program that's primarily going to be for vendors that do business with the federal government. And that's the Cybersecurity Maturity Model. I don't know what the other C is for. You can look it up. Either what it is, but it's a standard. It has 5 levels, so you can be audited and accredited or certified at one of those 5 levels, depending on who you are, who you do business with, the federal government, and everything else. My hope is that CMMC standard, and there's about 300,000 businesses that are going to have to get audited and certified because they do business with the federal government, becomes a standard way for us to communicate with one another about our security posture. And then from there, that serves as a framework to change the requirements we all operate in, within the government and business in the US and abroad. So that's my hope. It may be naively optimistic, but I do think it's the first attempt we've really had here to set a standard at all, right? I mean, before that, it was ISO 27001. And unless you're a giant multinational with all these other requirements, you're never going to do that to yourself. You'll never be able to afford to do it. Right. Or you had like SOC 2, which is an extension of financial controls. And that was accepted because it existed, not because it was any good. So I think having a security specific system around CMMC and all of that, giving businesses a way to exchange and coordinate this information amongst one another, creates a framework to potentially do more at a collective level, whether it's through regulation or otherwise.
Mm-hmm. And CMMC's really heightened awareness too, Chris. Mm-hmm. Yep. The fact that that's there is making everyone, reopen that cabinet and pull out what they've done. And I'm with you. I hope that it will all give them, give all of us a standard way to look at where you're at on the curve of protection with regard to what CMMC is regulating.
Yeah, and then again, if we have that standard way to exchange, where we're at with it, it just makes it so much easier. Because otherwise, every one of these security surveys, even when they're small, they're a project, right? You have to stop what you're doing, figure out how you've been asked these questions and how you're going to have to answer them and what's the format. We can get past all that.
Well, yeah, because you can spend hours a week doing that from all the different sources you're having that come in different formats, like you said.
Yep.
Yeah, it's good.
Definitely
it's been very interesting.
Yeah, definitely a forklift for sure. It's not a fun task as you get more and more vendors out there. And there's, like you said, all the IoT vendors at the beginning, and everyone's asking for a different survey. So definitely interesting. Chris, absolute pleasure having you on here today. And I love the AI conversation. Security is always a big topic, and just getting to know your industry and ATS better. It's been a pleasure having you on. So thank you for joining us.
No, I was glad to share.
And Jeff, always good having you on. Thanks for coming in too.
Yeah, glad enjoyed this conversation and appreciate your insights, Chris.
Absolutely. All right. Thanks, gentlemen. We'll talk to you soon.
All right. Talk soon.
Thank you.
Bye-bye.
Well, that wraps up the show for today. Thanks for joining, and don't forget to join us next week as we bring another guest in to talk about the trends around cloud contact center and customer experience. Also, you can find us at adleradvisors.com, LinkedIn, or your favorite podcast platform. We'll see you next week on another Cloud Podcast.